Okay, good morning, good afternoon, good evening, wherever you are. So today we're going to move on to 17F. So I think last lesson we covered 17D and E. I was going to do a couple of questions, but I think I did the last one out of 17E. So hopefully that's all gone all right. Conditional probability is a little bit trickier. So conditional probability, it sort of involves the word if or given that. So if you roll two dice, what's the probability that you throw a 12? The probability would be 1 out of 36. What's the probability that you throw a 12 given that the first dice is a 6? Oh, well that improves your chances, doesn't it? Because to throw a 12 you need a 6 and a 6. So you're then down to, well, just what happens on the second dice then, and so the probability would be 1 out of 6. What's the probability you throw a 12 given that the first dice is a 2? Nothing, 0. Because if you've got a 2 on the first dice, there's no way you can get a total of 12. So conditional probability, means, if this has already happened or given that something has already happened. So, it can be quite tricky, I guess, for you guys second language students, what do these words mean? And sometimes the words are a bit tricky. So let's look at some examples. So in their example there, let's have a look through what they've got in theirs. It's going to rain. Okay, if it is raining in the morning, there's a 90% chance that I'll bring my umbrella. If it is not raining in the morning, there's only a 1/5 chance of me taking my umbrella. On any given morning, the probability of rain is 0.1. Probability of rain or not rain. 0.1, 0.9. Okay? If it rains, the probability of my umbrella, that I have my umbrella, is 90% or 0.9 for an umbrella. Therefore, it's 0.1 for no umbrella. If it's not raining, then the probability that I take my umbrella is only 1/5. I'm going to call that 0.2 and 0.8. So umbrella, no umbrella. So the probability that it rains and I take my umbrella is 0.1 times 0.9 is 0.09. The probability that it rains and I don't take my umbrella is 0.1 times 0.1 is 0.01. Probability it doesn't rain and I take my umbrella is 0.9 times 0.2 is 0.18. The probability that it doesn't rain and I don't take my umbrella is 0.72, 0.9 times 0.8. So, if we've done that correctly, then those four probabilities must add up to 1. I'm sorry, I haven't run off any other sheets.
I just checked the sector.
Yep.
It's no video 9.1 and 9.2.
How long ago did you check it?
Just before I came up.
Like 5 minutes ago, 10 minutes ago?
Yeah, only like that.
Well, check it again now.
Okay.
Brian's just been helping me. Okay, so those certainly add up to 1. And this is kind of good stuff here. Hey. All right. So now, if we've got conditional probability, what's the probability? So, in the question here, the question that I've asked, if you see me with an umbrella, what is the probability it was raining? Alright, it's a conditional probability because there's an if in there. If this is happening, given that you've seen me with an umbrella, what's the probability that it was raining that morning? Alright, so if you see me with an umbrella, if you're with an umbrella, it's either that or that. Probability of an umbrella equals 0.09 plus 0.09. equals 0.27. This is an umbrella and this is an umbrella. 0.09, 0.18 gives us 0.27. Probability raining and umbrella equals probability of raining and umbrella is 0.09. Therefore, the probability of raining given umbrella equals 0.09 over 0.27 equals 1/3. Hopefully that's what we want. Okay? In general, that the probability of A given B, probability of A given B, probability of A given B equals the probability of A intersection B over the probability of B. Alright, so that, let's perhaps write it in one formula here. Probability of A given B equals the probability of A intersection B over the probability of B. It's in the data booklet, but that's an important one. So, let's look at one of the questions here. We'll do a couple of the ones here. There are 10 questions in this bit, so let's do one let's do question 3. So 17F, question 3. I don't know how to pause this video, so I've got to just keep on going. I can close it, but then it makes it 2 separate files, and then twice, a bit more of a job to keep going. So I'll be, maybe 5 minutes just to finish this off here. A couple of questions. Okay, so this is 17F, question 3. Probability of A is 0.6. Probability of B is 0.2. And the probability of A union B is 0.7. Okay. So we can draw a Venn diagram for that. There's A, there's B. So I know that the probability of A union B is the probability of A plus the probability of B minus the probability of the intersection. 0.7 equals 0.6 plus 0.2 minus the probability of the intersection. I could rearrange that, I'll just work out that therefore the probability of A intersection B equals 0.1. I can fill these in now. 0.1 in here. A must be 0.5 out here. B must be another 0.1 out here. 0.5 and 1.1, there must be 0.3 out here. That seem reasonable? Is that correct? So, probability of A is 0.6, probability of B is 0.2, probability of A union B, 5, 1, 1 is 0.7, there must be 0.3 out the side. Okay, so that all fits. Now, what do they want us to answer? Hence show that A and B are not independent. Probability of A intersection B equals 0.1. Probability of A times probability of B equals 0.6 times 0.2 equals 0.12. 0.1 is not equal to 0.12, therefore not independent. Okay? The next bit is a conditional probability one. Probability of B given A. Probability of B given A. It's not the same as the probability of A given B. Alright? So what's a probability to get a total of 12 given I've got a 6? What's a probability I get a 6 given I've got a total of 12? Different questions, different answers. Probability of B given A is the probability of B intersection A over the probability of A. You're given A, so that then gives you a restricted sample space. You're told that A has happened. So we're down to just that 0.6. What's the probability of B given A? It's that 0.1 out of 0.6. It's equal to 0.1 out of 0.6 equals 1/6, or yeah, we can write that as a decimal. Okay, let's try one more question and then you're on your own. I guess we do the last one, question 10. It's presumably the hardest one. Or maybe I should leave the hardest ones for you guys and just do an easy one. That would be a good idea too. Yes, Conditional says, oh, do this one. Question 10, so we're still in the same chapter, 17F. Question 10. Probability of A is 2/3. Probability of A given B is 1/5. Probability of A union B is 4/5. We want the probability of B. Okay. So, presumably quite a tricky one. So probability of A given B is the probability of A intersection B over the probability of B, and that's equal to 1/5. Alright. So probability of A intersection B equals 1/5 of the probability of B. Alright, I think we're going to get here. So the probability of A union B is the probability of A plus the probability of B minus the probability of the intersection. Right? Well, that's going to be true in any situation, not just for independent events. Right? Does that come up now, Om?
Yep.
Hey! So the probability of A union B, right, I know the A union B, so 4/5 equals the probability of A is 2/3 plus the probability of B, that's what I want to find, minus 1/5 of the probability of B. So I've been able to get, I've got one unknown. I had two unknowns, the probability of A intersection B and the probability of B, but the probability of A intersection B is just 1/5 of the probability of B from that bit there that they gave us. So, 4/5 equals 2/3 plus 4/5 times the probability of B. The probability of B minus 1/5 of the probability of B leaves me with 4/5 of it. Okay, let's take away 2/3, I better get them as 15. So it's 12/15 minus 10/15, so 4/5, I'll do it in 2 steps. 4/5 minus 2/3 equals 4/5 probability of B. 4/5 minus 2/3, what's that? That's 12/15 minus 10/15 is 2/15 equals 4/5 the probability of B. I'll stick on the same bit here. Multiply both sides by 15, I guess. So 2 equals 12 times the probability of B. So the probability of B equals 2 over 12 equals 1/6. Hopefully that's the right answer. If not, then blame Conditional. Alright, so that's 17F. I think that's, so Dr. Tenko is going to try and put some problem sheets up on sector, so I've still got to try and attach that to sector, but if you're looking at this, then clearly I have successfully. And Dr. Tenko will put up some files, some worksheets for you to go with that. Again, with standard level, there's not a panic, but we want to be able to spend as much time as we can revising. I'll make a video at home for 17G. 17G is sort of exactly the same, except it involves 3 areas. So it's 3 interlocking circles. So you've got that, and that, and so that makes it a step harder, of course, but hopefully not a problem. Okay, we'll call it quits at that.